Hey everyone, my name is Prashant Kulkarni. As Eric said, I got to know Eric through one of the DevSecOps course I took with him, which was very enlightening. I really enjoyed that. So here I am to talk about how you can secure your multi-cloud and hybrid cloud integrations without using secret. So it's a very sensitive topic and it's very dear and near to my heart because I spend a lot of time with my customers talking about this, helping them secure their workloads. Just to get some terminology out of the way, workloads are typically a specific projects that help you solve a solution or a broader problem that you're trying to solve on any cloud platform, though it's AWS, Azure, or Google. Hybrid is a terminology that we use or in general use in the market when you have workloads that span across your on-prem and a public cloud environment. And multi-cloud is obviously when your workloads span across multiple clouds. So you run a part or a complete workload on AWS and another similar workload on Google Cloud, or they share some infrastructure component. For example, use BigQuery on Google Cloud and use Compute on AWS. Typically, we see a lot of these multi-cloud and hybrid cloud workloads on Google Cloud, in addition to workloads that run exclusively on Google. So why customers choose hybrid and multi-cloud? This is a great question. In the past, when we saw when cloud was rising, typically customer use cloud for one set of application, but now more and more cloud migrations are happening, and more will happen in the next 20 years. So you will see this a very common scenario. Obviously, I'm not going to go through all of this. You guys pretty much know what it is, but just I wanted to just put out some points so you know where. And I have several customers that use a flavor of this, reasons to use multi-cloud. So going from this, how typically customer access Google Cloud from either on-prem or from other clouds. So on the right side, you see Google Cloud Project that has a boundary. Within Google Cloud, you have a GCP service a resource. There is a BigQuery or some other resource that has a Cloud IAM access. Typically, customer create a service account. As you know, service account is a fundamental entity within Google Cloud ecosystem. Service account represents a workload. Service accounts are double-edged swords. So they are resource as well as they are principal. Principals means they can act on resource, and resource means someone can act on service accounts, right? Something like impersonation. You can impersonate a service account. So customer creates a service account, then assign the required permissions, and then create typically a service account key. Service account keys are private public pair. So you get the private pair, and the service account resource has a public part of that pair. The key is downloaded, the private key is downloaded to the workload, and then that key is used in addition to the service account email as a user ID password. Think of that as a combination to access the credential endpoint. Once you have the credential endpoint, you get a access token, and then that access token is exchanged to get a service account specific token, because that's what you need to access this the resource that the service account has been granted privilege to. Well, what's problem with this? You've obviously seen downloaded key, which is a static key. It's easy to create, right? Obviously, you can just log into a project or use G-Cloud command or APIs to create a key. You can download the key, of course. So the downloaded key can be easily shared with other team members, right? Or you can sometimes bundle it with the app and push the app to GitHub. Has happened several times, right? And this key is lost. Sometimes it's just people don't know where it is, right? It's not rotated often. Recently, we started supporting key expiry, so that could be one reason that the lost key could be expired and not used. Also, we supported disabling and deleting the key, of course, in the past. But typically, customers do not want to disable the key because they don't know what workload will stop working, right? Very risky scenario. Um, of course, the key is prone to leakage, right? So it can be leaked either through, workload, the app deployment, or it can be committed to GitHub, and that's where the problems happen. Well, if you don't believe me, this is one of the cool site I found where actually they set up honeypot on AWS to see how the credentials can be abused. So they created basically AWS client ID secret pair and then pushed into public GitHub repository. And using CloudTrail, they monitored how attackers are able to exploit the key. The first attack that was actually saw was within less than a minute. So they were able to basically get hold of the key and run describe instances and get account authorization details API call. So these are the two basic API call that tells you what the AWS account has privilege, basically what kind of instances it can have, and what kind of authorization the account has. And this attack, basically the full attack, took less than 4 minutes from the moment of exposure. They did another thing. They actually bumped up the privileges of that account. They created a new dummy user, assigned a read-only permissions to EC2, and then allow that user to register and re-register container instances for EC2. Within 1 minute of exposing that user's key, the EC2 instance received more than 1,000 run instance API calls. And what they have seen is basically all those API calls are typically for the largest available instances, typically to find out if the instances are GPUs or if they're large enough so crypto mining can be run. That's a very widely used API call and very widely used exploit technique. By examining the logs, they actually saw that the attack came from 547 unique IP addresses. So even if you try to disable an IP or block the IP, that typically does not work. Hackers actually use proxies to divert the traffic. And these were all one thing to note, like there is nobody sitting on the other end. These were all bot-based calls. So things are getting increasingly risky and complex and scary when you see bots being involved. So the lessons is detection isn't enough, right? Not every organizations have tools and staff to detect and correct issues like these. Abuse notifications that are sent by AWS and Google Cloud send similar notifications. They typically go unnoticed because these are email notifications. People get hundreds of emails, thousands of emails. I don't know if you guys have that, but my aim is to get a zero inbox at the end of the day. I never managed to go do that. So I'm sure you guys have similar issues. So the email that is not directly addressed to you or looks like a spam email does not get noticed at all. So even if you realize that something has happened, like a leak has happened, there is not just enough time to remove the credentials because they're already copied, they're already downloaded. So even if you remove at that time, let's say you remove in the second hour, all the attacks that typically has happened in 1 hour, in the first 1 hour. So it's really meaningless to remove it anyway. The most important thing I see from this is cloud provider has a responsibility to provide most secure API access, most secure way of accessing their APIs or console for that matter, right? So how do we address it? How do we address it on Google side? So we introduced something called Workload Identity Federations about 2 years back, which was very well received by our customer. The way we do it is we actually provide you a way of using temporary tokens or tokens to access the API. You do not need to use API key service account keys. You just use a mechanism called Workload Identity Federation to access the APIs. And we'll see more on that, how you can do. So what do you need basically? You need an identity provider. That's all you need. You actually need either one of these identity provider. If you're calling a Google Workload APIs from AWS, you can use AWS metadata server as an identity provider. Similarly, Azure has a metadata server that you can use. Or if you're calling from on-prem, in case of hybrid workload, you can actually use your on-prem OIDC or SAML provider. Um, we'll talk about later, but there is also initiative to use PFI and Spire as an identity provider that are typically created for workloads. So what are the different steps to do this? Typically, as you know, Google Cloud has a project. All the resources lives in a project. So you'd create these workload identity pool in a project where your resources lives. The workload identity pool basically is a IAM construct in Google Cloud Project that would have a configuration of what your identity provider look like, right? If it's an AWS, then we have pre-configured AWS and Azure for you. You don't have to do much unless you're using a custom logic of claims. But typically, you would just configure how the token look like in case of OIDC. Then you would grant the pool access to the service account that typically use. So think of this as a chain. A workload has a service account has access to workload, and the identity pool has access to service account. An identity pool is where you configure how your claims should be interpreted by Google Cloud to provide access. So in this case, you would have the service account that actually has the privilege. Your workload directly doesn't have any privilege. Your workload only has privilege to impersonate this service account. All right, and the next step, when you actually do runtime, you authenticate your workload with, so you basically get a token from your on-prem identity provider, pass it to Google STS, and then get access token and service account token. Access token is only used to exchange service account tokens. So ultimately, you get a service account token, which can be used to call the workload APIs. So these are the high-level steps. You can do this configuration either via APIs, G-Cloud, or console. All options are available. What are the common scenarios where you can grant a access to the service account? So this is basically, you could say, a single identity access. So someone with an audience value or a subject value from the OpenID Connect token directly has access. So those are called principal. You can also say, well, a group of people can access this. So that is called principal set. And your group name would be given here. So typically your subject in the OpenID Connect token will have group. You could also do an attribute value pair. So you could say if the account has this attribute and a particular value, provide access to that account. So any other value would not get access. Or you could do a wildcard, which I do not recommend, but that option is certainly available. Typically, I've seen customer use option 2 and option 3 the most because they have set of workload that they want to grant access to a resource on Google Cloud side. So how does the solution look like? So in this case, I have taken an example of AWS, where your workload is running on a compute instance, which has a role, an IAM role. That IAM role actually has a policy that has something called a Google provider, and that provider will basically talk to the Google Cloud to basically interpret the Google token. So in this case, what is happening? The compute instance is able to get access to the AWS token through AWS STS. The token is passed to Google Cloud STS. The Google Cloud STS verifies the token, make sure it is a valid token, that it is coming from a valid AWS account, because that's what you would have pre-configured in the identity pool. Once that token is verified, then you get a service account token at the end of it. And basically, what is happening here is the EC2 instance is allowed to call the workload by way of impersonating this service account. Opposite is also true, how you can call an AWS resource from Google Cloud, and I'll cover that in the second part. So at the high level, the red arrows is how you would get access to a Google Cloud resource from AWS, and the blue is how you get access to AWS resource from Google Cloud. So just keep that in mind. We'll come back to this later. How do you actually use the technology? So you could use either via a client library. We provide several programming languages. If that is not sufficient for you, then you can actually do a manual token exchange. There are 4 steps to do it. First one is I typically explained these previously. So if you recall, the way you would do it is you get an OpenID Connect token from your provider. AWS and Azure are pre-configured, so you do not need to do this. Just use the um, library, and the library will do the work for you. But if you're calling from on-prem, let's say Ping Identity or SiteMinder or Okta, these are the and if you're not using a supported programming language, you can do these 4 steps to get access to the API using Workload Identity Federation. Right. So how does it look like? So this is before and after. So this is a service account file. Workload Identity Federation also generates a tip JSON file similar to what you have seen previously with service account key. In the service account key file, so on the left side before, that is the legacy service account file or the key file that you get when you generate a key and download from Google Cloud. You can see the type is service account and typically has a private key ID and private key. The private key is the one that is used to authenticate the service account, and the rest is a metadata typically. But the most critical thing is what is the email of the service account. So in this case, this is the email of the service account, and this is the private key that is basically used. This is the only way you can do it before workload identification. But with workload identification now, you can do it using this file. So this file, you will see the type is external account. It doesn't say service account anymore, and all it has is an audience value. Now that audience value is the one that is used by the library to locate your workload pool within your project. So you don't need to change anything like here. And then there is some metadata value. So in this case, you can actually see that it has a value of the Google Cloud metadata server, how you can get so get caller identity. So this is basically an AWS file. So this particular example was AWS example. So you can see it also has a AWS metadata values. And then finally, it has a service account impersonation URL, which would be called after you get the access token from AWS, which is exchanged with Google access token, and then that access token is passed back to this API endpoint to get the service account token. And that's it. That's the gist of it. It's extremely simple to use it as long as you understand and you have control. So what are the typical usage? Typical usage is if you have an application that you have control over the source code or anything else like that, you can use Workload Identity Federation today. If it's a third-party application, we work with a lot of third-party vendors to have them support workload identity as a technology. So if you're if you're one of those and you want to have a particular third-party support this, feel free to contact me. We work with them all the time. If they're a Google partner, they probably already have it on the roadmap. So this is the part we have seen where you can access a Google Cloud API or a resource API, workload API from outside of Google Cloud. And as I mentioned before, opposite is also true. You can actually call AWS API from Google Cloud. And we'll just see quickly how you can do that. So typically, this uses an API called Assume Role with Web Identity and with Google as an identity provider. So the way you do it, you configure AWS role basically, and then that role is assumed from outside of Google Cloud. There are certain configuration steps that are required, which are documented in AWS documentation that you can follow, and that will allow you to use AWS APIs. This is a code snippet. So this is a Python code that will work on Google Cloud that is trying to access AWS API. And as you can see, extremely simple code. Here is the role that I'm trying to assume. And then that role ARN is passed to the assume role with web identity API call. That gets me a credential object. That credential object can be used to get the access key and access secret, and then that can be used to interact with AWS API. Yeah, so that's my talks for today. I hope you guys enjoyed it.